Hello, everybody. Welcome back. We are on to our final unit, which is Unit 3. We made it. We're on the last one, home stretch. And this unit is going to be Unit 3, Sensation and Perception. Okay, so we'll start. This is technically the intro to sensation and perception. May want to write that at the top. So make sure to pause and, write down examples, and then make sure to take down everything I say. All right, so we're gonna start with the first one. First little section is going to be process and purposes of sensation perception. And so first bullet is going to be, so sensation and perception is basically where we process. It's a process in which we are going to detect and understand various stimuli from our environment. Okay. Next one is our senses is what allows us to get information from our environment. And then that information is sent to our brain. And then our brain is the one that makes the perception, right, of our world. So technically our brain is in darkness, right? Our brain really doesn't know what's going on around us. The only way that it's able to do that is through our senses. Okay, so our senses are really what interact with our environment. So those senses are, our hearing, our seeing, smell, touch, and taste. Okay, so those are your main 5 ones. And the ones we use the most is the, auditory and visual. All right, so we're gonna break it down into sections. In which we'll focus on sensation and then we'll go into perception. All right, so sensation is basically where it's processing of receiving stimulus energies from our external environment, okay? And then we transform those energies from our environment into neural energy, okay? So how this works is that our sensory receptors, right, from all of our senses are going to send that information to our brain, okay? So it's our sensory receptors, and then our nervous system receives that information from our senses, and then it's going to, through our spine, going to send it to our brain, okay? Now, how do they our senses pick this up? And it's basically that in our environment, there is energy, okay, that is in there. So there's physical energy, like light, sound, heat, and then our senses pick that up. And we have specialized receptor cells that basically are going to send that information. It's going to transfer that energy that's on the outside to neural energy. And then that is how it's sent to the brain. Because remember, we are electrical beings, so the stimuli from the environment needs to be converted in order for our brain to process that. Okay, and then in our senses, there are specific cells that their job is to convert that external energy into neural energy to send it to the brain. Okay, now, perception, okay, is basically the process of organizing and interpreting our sensory information. And this is all happening inside the brain, okay? Now, this is also the part where it's going to give it meaning to the objects or events, all right? And you'll notice that our brain is very smart in picking up patterns, because if not, imagine if our senses were constantly picking up every little thing and relearning it. So our brain likes to look for patterns, which can be very good, but it can also be a little bit negative, right? All right, so then we move on to what's called bottom-up processing and top-down processing. So bottom-up processing is basically where we start to process information using our sensory receptors, and then from there work our way up to higher levels of processing. So this is kind of like where we start at sensation, which is our senses taking in the information, and then up would be the perception, right? Our brain. So how this works is that our sensory receptors are going to register the information from our external environment, and then that sends it to the brain, and then our brain tells us what it is. Okay, now we typically don't use, as we get older, we don't use so much bottom up processing, because the more we are exposed to things, right, the less we're going to like look down, like look at the exact detail to try to figure out what it is. Okay, now as we're learning something new, we do that bottom up processing. So if I'm looking at a picture of a chair that I've never seen before, I'm gonna look at, my senses are gonna take this in, and they're going to, get that converted into neural energy, and then my brain is going to put that together to then create kind of like a schema in which, oh, this is a chair. Okay, so like for instance, if for this picture here, if I just tell you use bottom up processing, just look at it in detailed, every little thing, you're gonna start seeing, yes, you're gonna start seeing some trees, but if you look closely, you're gonna start seeing faces that are in the rocks. And then that would be kind of like bottom up processing. If I ask you, okay, look for the faces in this image, then you're most likely going to use bottom up, because you're using your senses very clearly trying to find it. Now, top down, right? It's kind of like top down, which is you're going to start with your cognitive processing. And then from there, which is the highest level, then it's going to kind of send it to our senses of this is what you see. Okay. So we're going to use prior knowledge with top down processing. And then we will, kind of like a negative with this top down is that it does create kind of like stereotypes. Okay, where if I told you just look at this image, you're gonna just see kind of like a forest with trees, rocks, two cowboy, or like somebody on a horse, maybe a cowboy, and then there's water, right? So that's kind of like your top down, because you already know these images, they're in your schemas. But if I tell you to look closely for faces, which is not the typical schema, then you're using bottom up. Okay, hopefully that clarifies it a little bit. All right, then we're gonna go on to sensory receptors and the brain. So sensory receptors are basically all of our senses have this, okay? And all sensation starts with sensory receptors, okay? Which are specialized cells that detect stimulus information from our external environment, okay? And they transmit it to our sensory nerves, and those are called afferent. And we learned about this. The afferent is our senses, right? Senses receive it, okay? Then those afferent nerves are going to send that information to the brain. Then that brain processes that information, sends it through the throughout your efferent neurons or nerves, and then that tells you what to do. Okay, so just remember these: the afferent and efferent. Okay, so that you know that's afferent is the one that's receiving it, and efferent is kind of telling you what to do. All right, now there is a keyword here for this unit that you need to know, and it is the word transduction. Okay, and very, very important. And transduction is basically the conversion of this neural energy, sorry, not neural energy. It's the conversion of that external energy that our senses received and converting it to neural energy, all right? Now, what you need to know is where it happens in each of our senses, okay? So once it turns into neural energy, that's when it's sent to the brain. Okay, so that's transduction. All right, then we're going on to thresholds, right? Which are basically what is the minimum amount of stimulus energy in the environment that needs to happen in order for us, our senses, to pick them up. Okay, now you're gonna learn there's some people that pick up minimal amount of sensory external stimulus from the environment, and others take, it's a little bit more difficult to get. Okay, but there's different kind of thresholds that you need to know about. The first one is going to be an absolute threshold. Okay, and you need to know this guy, Gustav Fechner, and he basically said this is the minimum amount of stimulus energy that a person can detect 50% of the time. Okay, so absolute threshold is basically that minimum amount of stimulus energy that is needed in order for us as humans to pick it up, but 50% of the time. And what they say is that this varies with each person. Okay, now our senses have very low absolute thresholds that we can actually detect small amounts of stimulus in our environment, as long as there's not other stimulus energy around. Okay, and so there is this little chart here that you definitely need to know. You need to make sure to write it down in your notebook, and it's basically, this is the absolute minimum that needs to occur in order for us, our senses, to pick it up. But again, 50% of the time. So for vision, they say that we can see, the human eye can see a flame from just one candle 30 miles away. And so I would say 30 miles away is from like our school to Broward. Okay, so however, there has to be absolute darkness in that. Okay, so there can't be any other light, nothing, but they say we could see a flame 30 miles away, one flame from a candle. All right, the next one is going to be hearing. Our hearing, the absolute threshold for hearing is going to be listening, being able to hear the ticking of a watch that is 20 feet away. Again, there can't be any other stimuli in the environment. The next one is going to be taste. Our absolute threshold would be just 1 teaspoon of sugar in a 2-gallon water, which basically means that we'll be able to taste that sugar in 2 gallons of water, but again, 50% of the time. The next one is going to be smell, that we could smell 1 drop of perfume in a small house. And then the last one is a touch. The absolute threshold would be we could feel the wing of a bee brushing against your cheek. Okay, so those are our absolute thresholds. How they tested it, no idea. Good way to go research that, but quite interesting. All right, then we're gonna go into signal detection theory. And this is basically where it's kind of like it's going to predict when we will detect the weakest signal in our environment. Okay, now we seek to understand why certain people respond differently to the same stimuli. All right, and they believe that, let's say, depending on your experiences, your the way your mood, expectations, all of those are going to influence your absolute thresholds. Okay, and sometimes people can go beyond, right, their typical absolute thresholds depending on their experience, alertness, and expectations. Okay, so for example, signal detection theory, as let's say a mother, when a new mother has a newborn baby, right, they could be in the room totally sleeping, passed out, and they could hear like the slightest movement from their baby, right? So usually new moms can hear the newborn like instantly moving when nobody else can. Okay, but that has to do with their expectations, their alertness, right? People that are deaf, right, deaf or hard of hearing, they can have, a really good signal detection theory when it comes to their sight. Like they could see like the finest detail that maybe somebody else can. Teachers, right? Teachers can have, because of their experiences, they can notice like that slight little change when somebody's like not paying attention or they're on their phone, right? And nobody else might have noticed, but a teacher may be able to do that, right? And that is just because of experiences and expectations and so forth. Okay, then they also have what's called difference thresholds, all right? And difference threshold is the degree of difference that must exist between two stimuli before the difference is detected, okay? And sometimes this is called just noticeable difference. And you may see that, okay? So they could use it either or. Just noticeable difference is, that says difference, but okay. It's that smallest difference that you feel between two stimuli. So, and again, this is going to be for 50% of the time. So for instance, let's say I am making, lemonade, like powdered lemonade, and I start with like, I don't know, whatever, like the recommended amount. And then I try it, but it doesn't taste just quite. So then I start putting like a little bit till I notice that slight difference. Okay, so it's just that it's noticing the difference between the two stimuli. This can also be based on, so it could be like another example, like salt, right? Like you put a little bit of salt and you don't notice a difference until you notice that slight little difference of how much salt, okay? Then there's what's called Weber's law, and Weber's law has to do with proportion, okay? And this is when you're able to notice that slight difference in proportion to something, okay? So it can be in, in a picture. It could be in a weight of something, okay? Like if I put two sheets of paper on your hands and then I start, putting more books or paper, it's noticing that slight difference. Like there needs to be a proportion to know, like one sheet is not going to make a difference, but a ream would, okay? So that is basically for that. Then we have subliminal perception. And this is basically stimuli that is right before your absolute threshold. A lot of people say this is that detection of information that is below our conscious awareness. This is where a lot of people are like, oh, they're throwing like subliminal messages that we don't notice because it's not in our conscious mind. Now, under certain conditions, it can be affected by stimuli that's so weak that you don't consciously notice it. Okay, it could be a flashing of something quickly. They've said this about Disney movies and such. So there's that. Okay, now we're going to go into attention, because in order for us to process anything in our environment, or all of these energies that are out there, stimulus that's out there in our environment, in order to really understand it or get it, is we need to be paying attention, okay? And so there's different ways of paying attention. So the first one is selective attention. And this is when we're focusing on one specific aspect of something and ignoring the rest, okay? So this is when, let's say, you're watching a movie on your phone and you're like oblivious to everything that's going on, even if, let's say, that somebody's calling your name, okay? Now, typically, if somebody is calling your name, we have that cocktail party effect. And that is under that selective attention. Might want to add it in there. And that's our ability to attend to either one voice amongst many, or it can also be like we're in a very stimulating environment, but we can hear like somebody call our name or a distinct voice. Okay. And there, obviously, motivation, experience has a lot to do with that. Okay. Now, there is what's called the Stroop effect. And this is an example of Stroop effect. And I'm sure a lot of you have seen it. And this is basically where they tell you, okay, you're going to say like the color of what's here instead of reading the word. Okay, so like it's very easy for us to read this like blue, green, because it's the color of the word. But if they tell us, okay, tell me the color of that they're using, it takes a little bit more time. So we have to use selective attention to really focus on that. Okay. Now, we also have what's called change blindness. And change blindness is something that magicians use this all the time. Oh, I'm sorry, hold on, let me go back. So, inattentional blindness is where our failure to detect an unexpected event when our intention is engaged by a task or doing something. Okay. So inattentional blindness is when, those people that are texting on the phone while they're driving, and here comes Miss Lombana honking like, hey, why are you going like 40 miles an hour on a highway? That is called inattentional blindness. They are, because they are selectively attending to their phone and they are blind to everything that is around them. Okay, which also goes into change blindness, because change blindness is basically our inability to see changes in our environment. Okay, because we're not paying attention. So we won't notice that something has changed because we're not paying attention. Okay. Magicians use this. They usually are like, hey, pay attention over here while I do something in my other hand, so you're not paying attention. Okay, so you don't notice the change. All right, there's usually this really famous study that they did, and if you watch Brain Games, they have this, in which they had these people like counting people that were dribbling, how many times did they dribble the ball. And since people were focused on that, what they did in the experiment is had somebody dressed in like a gorilla costume and walk in the back. And then they asked them like, oh, did you see the gorilla? And nobody had seen the gorilla because they were counting the basketball. Okay, so that's change blindness, but it's also part of inattentional blindness, because you're not focusing. You're focusing on one thing and ignoring everything around. Okay, and then the last one you need to know is divided attention. We've talked about this, and divided attention is basically when we are multitasking, right? We are splitting up our attention into multiple things, and like the research says, it is not effective. Okay, it's hard for us to deep process that. All right, now forgot here. All right. Okay, and the last little section is going to be a sensory adaptation, okay? And this is basically how our senses adapt. So the first thing you need to know is about perceptual adaptation. And perceptual adaptation is basically the ability of our body and brain to adapt to our environment and filter out distractions, okay? So this is where a lot of times our brains are gonna look for patterns so that we don't have to process every little thing. All right. And then our senses, our sensory adaptation, which is really cool, is that after being exposed to a stimulus that does not change, right? Like the stimulus is not changing, it's not increasing, decreasing, it stays the same. We become less aware of it because our nerve cells basically stop, they fire less frequently. Okay, so for example, if you put on perfume, right, in the morning, and then you're like, 30 minutes later or an hour later, you don't even smell it anymore, right? And that's because it's still there, the chemicals are still there, the stimulus is there, it's still there, but it hasn't changed. Until if you put more, then it increases, right? The stimulus, you smell it again, and then your sensory adaptation will make sure you don't smell it, right? Until you like get a little closer maybe and start smelling your hands or wherever you sprayed, and then you'll be able to smell it again. But then it's gone again. Same thing with as you're watching like TV, right? Or even YouTube, and they do this all the time. Because of sensory adaptation, like they know that you could be watching like TV or YouTube, and then all of a sudden they'll put an ad, and the ad is at a higher volume. And they do that to get your attention, basically. So that's a little tidbit there that they do. Then the next thing you need to know is habituation. We've talked about this before. And a habituation is basically we stop showing an interest, right? Or stop processing a stimulus because we are like used to it, okay? So that is habituation. And that's it for this little section. On to the next.